students, welcome back to Organic Chemistry. In the last lecture, we have seen how to name the alkyne molecules. In this video, I'm going to teach you how to name the dienes, diynes and alkenyne molecules. Dienes are the organic molecules with two double bonds in the molecules. Now, based on the placement of the double bond, the diene molecules can be classified as conjugated. That means what? The double ion single bond are in conjugation with each other. That means they are alternative. Double single double bond like this. Or they can be cumulated. Cumulated refers to the double bonds are next to each other like in this molecule. And then isolated. Isolated can neither be conjugated nor cumulated. That means what? The double bonds are being separated by sp3 hybridized carbons like CH2 in this molecule. Now, how to name these diene molecules? In general, they are named as alkadiene molecules. Alkadiene. So, all of them put together, you can call them as alkadienes. So, if there are 4 carbons, say 1, 2, 3, 4 in this molecule, then it's a butadiene. But where is the double bond? The double bond is at the first carbon. And where is the other double bond? At the third position. Therefore, you can call this as 1, 3 butadiene. So, what is the UPAC name of the molecule? It is 1, 3 because at first and third position there is a double bond. So, 1, 3 butadiene. Similarly, for the cumulated, the double bonds will be always next to each other like 1, 2, 2, 3, 3, 4 like that, right? So how do you name this? There are 3 carbons. So first we will name that part. So it's a propadiene, right? And choose the longest chain like this, right? And the double bonds are at first and second position. Therefore, 1, 2 propadiene. Or you can even write it as propa 1, 2 diene. Either way it is correct. Now for the isolated, choose the longest chain of carbons, right? Since there are 5 carbons, I'm going to call this as 5 carbons pentadiene, right? Where the double bonds are at first and fourth position. Therefore, 1, 4 pentadiene or penta 1, 4 diene. Either way it is correct. Now, let's apply the same rules for the given molecules. So, choose the longest chain. I prefer numbering from here. Why is it so? Because if we number from here, you will have to number the double bond carbon as 3, right? So, it's not obeying the lowest locant rule. So, that's why. And there are 6 carbons. Therefore, hexa, first and third position, double bond. Therefore, 1, 3 diene like this. Now, for cumulated, so again choose the longest chain. These are bond line structures. So make sure that all the carbons here are in straight line because this carbon will be sp hybridized. That's why, right? So now there are 5 carbons. Therefore, you can call this as penta. And at second and third position, 2, 3 diene. So if they are adjacent, right? 2, 3. So alternative, say 1, 3, 5, etc. Now let's take this last molecule. So 1, 2, 3, 4, 5, 6, 7. There are 7 carbons. Therefore, I'm going to call this as hepta. What position we have double bond? 1 and 5. 1, 5 diene. These are some of the simple diene molecules. For the given molecule, choose the longest chain of carbons including both the double bonds, right? So the substituents are here, ethyl and methyl. Either we can number from here or here, but I prefer numbering from this position because it will obey the lowest sum rule. And also the double bonds are going to get the least possible number. Now, we have ethyl and methyl. Ethyl will get the priority. So 4 ethyl and then 3 methyl It's a alkenyne. So there are 6 carbons, therefore hexa 2, 4 diene. Diene. So you can see that 2, 4. That means it is always conjugated, right? Alternative double single double bond. Now, let's see for the cumulated molecule. If we take the longest chain, including both the double bonds, right? So this will be the longest chain. And it's a terminal double bond. So let's number from that position like this, right? So that means at third position, we have a substituent that is ethyl. Therefore, 3 ethyl and 5 carbons are there. Therefore, penta. At first and second position, there are 2 bonds, right? So therefore, penta 1, 2 diene. And it is cumulated, right? Now, let's see the isolated double bonds. So the longest chain here is, it should include the double bond. So this will be the double bond, which should be included in the longest chain. And if we number from here, the double bond will get the second number. But if we do it from here, least possible number. So always make sure that the terminal double bond will get the priority. And ethyl is a substrate. Therefore, 5 ethyl. There are 7 carbons. Therefore, hepta. At first position and fifth position, there is double bond here and here, right? So there are 2 double bonds. So diene like this. Now let's take the last molecule. This is interesting. See, the longest chain would be this one, right? It includes 1, 2, 3, 4, 5, 6, but it will not consider both the double bonds. So that is not correct. This is the correct way of taking the longest chain, including both the double bonds. So, and also the substituent should get the least possible number. Since there are 3 carbons here, I'm going to call it as 2 propyl and buta 1, 3 diene. 1, 3 means it is conjugated. So this is how we name the diene molecules, whether it is conjugated, cumulated or isolated. The organic molecules with 2 triple bonds in them are called as diene molecules. The general name of diene molecules is alkenyne. That means what? For the given molecule here, you take the longest chain. You see there are 4 carbons. Therefore, the alka group will become buta. And at first and third position, we have a triple bond 1, 3 and then diene. That is the UPAC name of the first molecule. It is straightforward and simple. Students, remember this is conjugated. That's triple, single and triple. Okay. Here it is isolated, but generally we will not have a cumulated. Why is it so? In order to be cumulated, the triple bond has to be adjacent. In that case, the carbon here will have 6 bonds, which is impossible because carbon is tetravalent. So we have either conjugated or isolated. So you have to remember that point. Now let's take the second example. Here I am writing bond line structure, but the rules are same. There are 7 carbons. Therefore, you are going to write it as hepta. By now, you know why I numbered from here, right? The terminal will get the first priority. That's why hepta. And at first position and fifth position, triple bond is there. Therefore, diene. Right. Now, let's take this molecule with substituent here. If we number from here 1, 2, 3. If we number from here 1, 2. So, triple bond should get the priority but not the methyl. Okay. So, however, you can number like this. There are 9 carbons and 2 triple bond and a methyl. So first you name the prefix. So 5-methyl. Altogether there are 9 carbons. Therefore nona and 2, 6 diene. Right? Diene molecule. Now let's take the last molecule. You see here, the substituent here is a tertiary butyl, right? Therefore, how we are going to name it like this. So there are 7 carbons, therefore, first you write the prefix, okay? So first we'll start from the prefix, that is the tertiary butyl. So 4 tertiary butyl, and there are 7 carbons, therefore hepta, first and 6th position diene, right? So this is how we name this molecule, but we can also name it as a dimethyl ethyl group. What does that mean? See, you choose this as a longest chain. So on the first carbon, there are 2 methyl. So you can name it that way also. So this part of the name will be same, hepta 1,6 diene. Just this part, we have to change it. So what does that mean? See, on the 4th position, what do we have? On 4th position, we have a ethyl. You write that here, ethyl. And then hepta 1,6 diene, right? But on the first carbon, you see there are 2 methyl. Therefore, on the first carbon, right, 1,1 dimethyl. And then close the bracket. That shows that these are the substituents on a substituent. So what will be the name of the molecule? 4 1,1 dimethyl ethyl hepta 1,6 diene. Now let's see how to name the alkenyne molecules. Alkenynes are the organic molecules which contain a double bond and triple bond in them. Whenever we number the longest chain in these molecules, it doesn't matter which one, number in such a way that the first group gets the lowest possible locant. Here you see the double bond will get the lowest locant. Therefore, we will number it like this. In the second molecule, here we number the triple bond first. Why so? Because that will get the lowest locant number. But whenever triple bond and double bond are terminal, in that case, the alkene gets priority over alkyne. You have to number the alkene first over alkyne. Why is it so? It's because it's something to do with the suffix. See, both alkene and alkynes, right? Both of them are suffixes. In that case, first you compare the E of ene and Y of ine. Alphabetical priority goes to ene. That's why we always name them as alkenyne. For the first molecule, there are 5 carbons. Therefore, it's a pentenyne. But where is the double bond? At the first position. Therefore, pent 1 ene. You don't have to write this E here because there is ine at the end, right? So that's the reason. Pent 1 ene, and see at the third position we have the ine like this. So it's a pentenyne molecule. Now let's take the second one. Here also we have 5 carbons, therefore pent, right? Here first you have to name the ene itself because the names are alkenynes, right? But the position of the double and triple bond will be different. So pent 3 ene 1 ine. The positions are different. That's it. Same with the last molecule also. So it's a, here we have 4 carbons. Therefore, you don't have to write pent, right? There are only 4. Therefore, but. And where is the double bond? At first position, 1 ene. And the triple bond is at the third position like this. So this is how you name the alkenyne molecules. Let's take some more complicated molecules and name them. Now that you have learned all the rules, it will be very easy to apply the rules for the given molecules. As usual, choose the longest chain of carbons. While numbering, make sure that the double bond will get the priority here as it is terminal. If it is not terminal, then choose the lowest locant rule. Now, the groups are isopropyl and methyl. Isopropyl will get the priority due to alphabetical priority here. Therefore, it's going to be 4 isopropyl. Iso is considered as a part of the prefix, that is isopropyl. That's why at third position we have methyl, therefore 3-methyl. The longest chain is oct and the double bond is at the first position, therefore oct 1-ene, and at sixth position we have the triple bond, therefore 6-ine. 4-isopropyl, 3-methyl, oct-enine. So oct 1-ene, 6-ine. That is the correct UPAC name. Now, for the next molecule, you see, this is the correct way of choosing a longest chain. It might not obey the lowest sum rule. That's okay because the triple bond is terminal and this should get the priority, and the 3-methyl, therefore how we are going to take it, 4,6,6 trimethyl. In the longest chain there are 7 carbons, therefore hept, and ene always first, so 4-ene, and there is 1 at the triple bond is at the first position, so 1-ine. So this is how you name the alkenyne molecules. Now that you have learned how to name the dienes, diynes, and alkenyne molecules, in the next lecture you are going to name the halogen compounds. Thank you for watching this video.